Okay, thank you. Today we're going to be talking about supernetting. Now, supernetting is another way to describe large networks. It could also describe aggregate networks. So what we could do is we could actually define networks that are included in a bigger range. In this case, we are going to talk about the /8 and /16 networks as supernets, but really supernets can be networks that are probably anything larger than /22. So these are networks that are aggregate networks. That means that their parts are created into a whole, but they can be described by using this particular notation. And what this looks like is it looks like an IP address here in the form, in this case, XYYY, that would be a /8, or XXYY would be a /16. Now, as we talked about network creation in other videos, we talked about how we look at the number of bits. In this case, we're specifically talking about the first 8 bits because of the /8 CIDR notation. In this case, the first 16 bits, the /16 CIDR notation, that represents a large network. So the network portion of this address is the 2 X's. The host portion is the Y's. And that's how we would define when we define a specific network that's large. This is what we would talk about. However, in a supernet, what we're talking about is mainly a way to filter things. So while this is still a relevant topic in terms of IP addressing, it also works in terms of filtering. I'll give you an example of what I mean by that. Now, I could create a network for a LAN, and I could create a /16 network, and I could say, well, this is going to be network 172.10.00/16. So obviously, this is my network portion. These are my hosts. Now, I can create all types of networks underneath this. I can define these subnets in routers to do whatever I wanted. I could have a subnet defined as 172.10.1, 172.10.2, 172.10.3. All of these networks are going to fall under the supernet. This applies in terms of filtering. An example is, let's say that I wanted to tell my device, whether it's a firewall or router, that I wanted to filter all traffic. So I would set a filter and say, if the source is 172.10.00/16, don't accept the packet. So in this case, what I'm doing is I'm creating an exception to a rule that allows traffic, and I'm saying identify the traffic that falls into this supernet. Now that is another application of a large network. So if I wanted to even cast my net even larger, I could use a /8. So in this case, let's say that I had an IP address of 12.000/8, and I want to restrict traffic. So any traffic that I find that falls anywhere in this boundary, as long as it starts with a 12 and it ends with anything else, we can call it as part of the supernet and filter it. We could also use, conversely, like I was saying before, we can use this supernet to calculate and create networks underneath it. So if I wanted to make a network that was a /24, I could do that. And I would have possible values of 12.0.0.0/255. If I wanted to make a network, for example, 12.1.0.0/24, that still falls under the /8 SuperNet, and it gives me the ability to recognize that this is a network boundary, and the possible hosts inside that are the completions of this last octet of the IP address. In this case, we would have a range 12.1.0.0, 12.1.0.255. So that is the application of the SuperNet. I could also draw a network up, and I could say, well, this network is 12.2.0.0/16. This is another network that we created. It's much smaller than the /8, but it's still encompassed by that 12.0.0.0/8. It's still encompassed by the SuperNet because the SuperNet definition begins with 12 and includes everything. So that's a slight overview of SuperNets. I hope you've enjoyed that. If you have any questions after watching that video, be sure and post them in the discussion for our class. Thank you.